Beautiful, beautiful, beautiful. Hello, welcome to our YouTube space. Today we want to continue with moles. This is part 2. If you have not watched moles part 1, check it on our videos. You'll be able to see it. So today we want to focus on moles part 2. So on moles part 2, we want to start at something called molar solutions. Molar solutions. So what is this molar solutions all about? Okay, so at least you have idea of moles. So if you take maybe a substance, for example aluminium, and let's say the moles of aluminium is maybe 0.5. So if you take 0.5 moles of aluminium and you dissolve it in a solution, okay, so if you take 0.5 moles of aluminum and you dissolve it in a solution and let the volume of that solution be 1 liter, remember 1 liter can also be 1000 cubic centimeters and it can also be 1 decimeter cubic. So if you dissolve it in 1 liter of any solution, you are going to get molarity. So molar solutions is all about dissolving a mole, dissolving any number of moles in 1 liter of the solution. So molar solution, as now my description on my notes here. Okay, so you can basically see that a molar solution is a solution that contains 1 mole of solute in 1 liter of the solution. The main important thing in molar solution is that you are going to dissolve it in 1 liter of the solution. So if you dissolve any mole in 1 liter, 1 liter is equivalent to 1000 cubic centimeters and also 1 decimeter cubic. Okay, this one. This, look at this, the conversion here. The conversion is here. 1 liter is equivalent to 1000 cubic centimeters and it is also the same as 1 decimeter cubic. Okay, good. Now that is so molar solutions. We'll be talking about dissolving moles in 1 liter. 1 liter is the same as 1000 cubic centimeters. There's also something called now concentration of a solution. So concentration of a solution, it can be expressed in 2 ways. So one of them, we can do it as grams per liter or we can do it as moles per liter. That is concentration. Concentration of a solution can be expressed in 2 ways. Okay, it can be expressed as grams per liter. That means that mass per liter, or moles per liter. So you'll basically see the 2 examples. So that is all that you need to know about concentration. So let's see an example. Okay, there's an example here. Suppose 4.0 grams of sodium hydroxide were dissolved in 400 cubic centimeters of distilled water, then made up to 500 cubic centimeters of solution. Determine the concentration in grams and in moles. So we want in grams and in moles. Okay, yes, so we want to find this thing in grams and in moles. Okay, so let's start with the grams. So we are going to equate this thing. So grams per liter, of course, let's just grams per liter. And also moles per liter, because we want the concentration. So let's start with grams per liter. Concentration, sometimes you can also find it in grams per liter. So you're just going to equate. Okay, remember 4 grams, it was dissolved in 400 cubic centimeters. Then it did not stop there. They later made it up to end at 500 cubic centimeters. So it means that it was dissolved in 500. You focus on the final, because in chemistry we dissolve this thing in bits. So sometimes you add a certain amount, then you later on you also add another amount, so you work with the final amount. So I know we had dissolved it in 400, yes, but you work with the final volume that was used to dissolve it. So you're going to equate it to 500. So it's all about the if statement. So we're going to say that if 4 grams, we were able to dissolve it in 500 cubic centimeters. Then, remember this is now concentration grams per liter. Then 1 liter in terms of cubic centimeters is 1000. So now we are going to ask ourselves, what about 1000? So that is the equation. Then this one is if. You just cross multiply. This times this, you divide by that. So this is if. This times that, divide by that. So ensure that whatever has the same units are on one side. So this times this, we divide by that. So that is 4 multiplied by 1000. Then basically we are going to divide by 500. So if you do so, you get 8. So that will be 8 grams. It will be in 1 liter, 8 grams per liter. So you can write liter L that way, 8 grams per liter. So that is the solution for grams per liter. Okay, what about the moles? Let's now do the one for moles per liter. So what about moles per liter? So moles per liter, we need to find the moles. So moles per liter. So we have the formula. Remember that moles is equals to mass in grams over molar mass. Okay, so we want to find the moles because this one is moles per liter. So we want to find the number of moles. So moles is equals to mass in grams over molar mass. So mass in grams, we have been told that it is 4. The molar mass, so we need to find it because this one is sodium hydroxide. Okay, it was sodium hydroxide, and that this is how you write sodium hydroxide, NaOH. So if you have sodium hydroxide that way, then you have the molar masses for individual components. So we have the molar masses because sodium has a molar mass of 23, oxygen 23, yes, oxygen has 16, and hydrogen has 1. These things are normally given in the bracket. In any question they will be given. Okay, yes, so these are the molar masses. So this one is sodium, oxygen, and hydrogen. So we are going to add them. Okay, so we only have 1 sodium, so that is 23, plus we have 1 oxygen, that is plus 16, and we have 1 hydrogen, that is plus 1. So it will be 23 plus 16 plus 1, so that is 40. So the total, the RFM for sodium hydroxide is 40. So you take 4 divided by 40, that is 0.1 moles. So you get 0.1 moles, sorry. You get now 0.1 moles. So I believe you have understood how we get the 40. So you write the chemical formula because they told us it was the sodium hydroxide which was dissolved, and this is the formula for sodium hydroxide, NaOH. And we have the molar masses. Sodium, which is Na, has 23, oxygen is 16, hydrogen is 1. So you add all of them, you get the relative formula mass of sodium hydroxide. So we have 0.1 moles. 0.1 moles. Then remember, concentration, you must equate moles to 1 liter. So we're going to say that this number of moles, that is 0.1 moles, it was in 500. It was in 500 cubic centimeters. Then what about if we could equate it in 1 liter, which is 1000 cubic centimeters? So again, you just cross multiply. So you do that, that will be 0.1 multiplied by 1000. Then the answer that you get, you divide by 500. So the answer that you get, you divide by 500. So if you do so, you get 0.2. Is it so? No. Let's divide this thing properly. Okay. Let me divide this thing properly. No, the lower one is 500. Yeah, it will be 0.2 because 0.1, the lower part was 500, not 50. So if you put that one on the calculator, it will be 0.2. So it will be 0.2 mole, 0.2 moles per liter. So that will be the answer. And remember, moles per liter, we call it molarity. So moles per liter is always molarity, capital M. Moles per liter is always molarity. Moles per liter is always molarity, capital M. So that is our answer there. So I believe you have idea of concentration. Let's move on to something. Let's now focus on molarity on its own. Molarity of a solution. So what is molarity of a solution? So molarity of a solution is the number of moles of the solute per liter of solution. So molarity, what is now molarity? Molarity is now the number of moles in 1 liter of a solution. So the number of moles. So if you can find the number of moles in 1 liter of anything, the number of moles in 1 liter of anything. So the number of moles in 1 liter of a solution is regarded to be molarity. It's very simple. So if you can find the number of moles in 1 liter of any solution any given time, so you'll always be having molarity. That's how simple it is. That's how simple it is. So there's a question here that we can do together. Suppose 71 grams of sodium sulfate are dissolved in enough water, then made up to 1 liter of solution. Determine the molarity of the solution formed. Then you are in the bracket, you have been given the molar masses, the respective molar masses of these elements. Sodium has a molar mass of 23, sulfur has a molar mass of 32, oxygen has a molar mass of 16. So mass, this is how you write sodium sulfate. This is how you write sodium sulfate, because sulfate is a radical, it has a valency of 2. Then sodium is in group 1, it has a valency of 1. So 1 from sodium comes this side, which you basically ignore, and now the 2 from the radical sulfate you place it on this side. So this is how you write sodium sulfate. So it was dissolved in 71. So the mass was 71 grams. Okay. They have used a different way of looking at it. So they have used the concept. They have used the concept. They have used the concept. So let me just do. Let me just show you. I was to show you what is written here, but let's do ours. So let's find the moles. Okay. But before we find the moles, let's find the RFM of this thing. RFM of sodium sulfate. So the RFM of sodium sulfate, what we're going to do here is to add these things. So sodium, there are 2 of them. Sodium atoms, there are 2 of them. So that will be 23 multiplied by 2. Because 1 sodium has a molar mass of 23. Then there is a single S, that is sulfur, which is 32. Then plus, we have how many? We have 4 oxygen atoms. That will be 16 times 4. So if you add everything, you get 142. If you add everything, you get 142. And we want now the number of moles. And remember, moles, according to our formula, moles is equals to mass in grams over molar mass over the RFM in this case. Because when you add all those molar mass, you get the RFM, that is relative formula mass. Okay, relative formula mass. Relative. Okay, like what is the difference between the RFM and the molar mass? Okay, here is the thing. The mass of 1 mole of a single element, we call it the molar mass. So the molar mass is ikiwa peke yake when we only have 1. So for example, sodium and the weight, sulfur and its weight, oxygen and its weight. So because of this, as you can see, that of its weight, that's of its weight, that's of its weight, as you can see, that one of its weight. So when you have sodium and its weight alone, sulfur. Sorry for that, there was a small distraction. That's why I was repeating that one a lot. Then we have now oxygen and its weight. So, but now the compound, when you now have a combination of all this, now you have your sodium, you have your sulfur, and you have your oxygen. Okay, so when you have a combination of all that, you get the relative formula mass. Okay, so but when you have a single one, sodium and this, sulfur and that, oxygen and that, so what you basically get is the molar masses. But if you add all of them, we now call it relative formula mass. So that's always the difference. Yeah. Okay, so moles would be mass in grams, which is mass in grams was 71 over the relative formula mass, which is 142. So you are going to get 0.5 moles. 0.5 moles. So you're going to get 0.5 moles. So that is what you get. But the question was asking about molarity. So we were focusing on molarity. Okay, so we were focusing on molarity. Now molarity, what is now molarity? I told you that molarity is the number of moles in 1 liter of any given solution. So they have told us that suppose 71 grams of sodium sulfate are dissolved in enough water, then made up to 1 liter of the solution. So it was dissolved in 1 liter of the solution. So already our 0.5 is the moles because it was already dissolved in 1 liter. So in this scenario, the 0.5 was our moles, but because it was in 1 liter, because this 0.5 moles, it was already in 1 liter. So the 0.5 is just our answer, molar. So molarity is 0.5. That becomes our answer. So the 0.5 moles was already in 1 liter. So because it was already in 1 liter, it is already our answer. Because molarity is the number of moles in 1000 centimeters cubic. So we'll proceed with more of these things. There's also the formula related to this thing. There's also a formula related to this thing, and now let's talk about dilution of a solution. Dilution, when you dilute a solution. There's always a formula around this thing. Dilution is a process by which concentration of a solution is lowered by adding more solvent into the solution. During dilution, the amount of solute remains the same as the volume of the solution increases. Let's look okay, let's say there is a juice, or let's say there is a quencher, the juice and all that. So something like that, you normally dilute it to your taste, then now you drink it. So, or alternatively, I can use an example like maybe you are preparing maybe what should you prepare? Maybe let's say even tea. Okay, you are preparing tea and you find that you have put a lot of sugar. So if you find that you have put a lot of sugar, what do? So you add some water to it. Remember, the amount of sugar remains the same. The amount of sugar, because now you find you have found that your tea is highly concentrated. Okay, and you don't want to dilute it. You don't want to lower the concentration of the solute. So you add more water to it. Remember, kiasi ya sukari pale ndani haibadiliki, ni maji unaongeza. So ni maji inaongezeka, lakini the amount of the solute itself does not change. Okay, so it is the volume of the solution that increases. So in the process you find that it will have a different taste, and of course the concentration is going to be lower. So that is now dilution. So there's always a simple maths concept behind it, and we don't want to check it out. So what is important in dilution is this. Yeah, this one. So here it is. Calculate the volume of a 5.0 molar sulfuric 6 acid solution that will be required to make 1000 cubic centimeters of a solution of 0.05 molar sulfuric 6 acid. So now we want to use this formula. In dilution we normally use this formula. In dilution, that is the formula that we use. This formula is molarity 1 times volume 1 is equals to molarity 2 times volume 2. Yes, molarity 1 times volume 1 is equals to molarity 2 times volume 2. So you just match them. Calculate the volume of 5.0 molar sulfuric 6 acid solution that will be required to make a 1000 cubic centimeters solution of 0.05 molar sulfuric 6 acid. So the formula is molarity 1 times volume 1 is equals to molarity 2 times volume 2. So molarity 1, because this is the first thing that we get, it is 5. Volume 1, so because if you read it, calculate the volume of this, so it means that this 5 molar does not have any volume, because read this English very well. Calculate the volume of a 5 molar sulfuric 6 acid. Calculate the volume of this, volume of 5 molar. So there is no volume of 5 molar. Then what about molarity 2? Of course, you can see that this 1000, it matches with this 0.05. So 1000 is our volume 2 and the molarity is 0.05. So then now you basically multiply it. You just substitute and multiply that. So just substitute, because we can basically substitute it. So molarity 1, so because we have all of them, so you're now going to substitute. So molarity 1 is 5 times what we want, V, is equals to molarity 2, 0.05 times volume, which is 1000. So what do you want? We want V. So if you want V, you divide both sides by what is next to V, which is 5. So because we want V, so you do that way. So volume, you get 10 centimeters cubic. So that's how you do it. Yes, because 5 multiplied by what you want is equals to 0.05 times 1000. Then now from that point you divide both sides by what is next to V, and you get that. So that is under dilution. So that is how you do it, under dilution. So there are plenty of things that we'll still be covering as we move on. So in our part 3 of moles, we'll talk about now stoichiometry of chemical equation. So that is where we'll start on in the next class of ours. So this one is moles part 2. Thank you so much. May you have a wonderful day. Bye-bye.